to the section on spheres, section 9.5 from the book. And this is the handout, and we'll go through the handout and in this video. First of all, we need to determine what is a sphere. We need to remember or decide. Now, the sphere definition is related to a definition of a circle. So can you take a moment to pause and remember what the definition of a circle is? Okay. The definition of a circle is the set of all points that are the same distance from a center. And the sphere is the exact same way because the circle is two-dimensional, the sphere is three-dimensional. So we can say a sphere is the set of all points equidistant or the same distance from a center point. Okay. Now the difference between the circle and the sphere is that this is in 3 dimensions. Okay, so in all 3 dimensions, not just the 2. Okay, we're going to go ahead and draw a diagram of a sphere and label the parts. Now the spheres are actually relatively straightforward. I'm going to try and draw a circle here. And then usually we draw like an equator or a line that goes through the middle of the sphere just to show that it's 3D. Okay, and a sphere has the center point. And so all of these points, all of these parts here are equidistant from the center. Okay. And there we go. Usually we draw a line here and we label this R. Okay. We draw it in a different color. We label this as R for the radius. Now, the radius of the sphere can go in many directions. Okay, so it can go up from the center point to the top point. That's also a radius. From the center point down to the bottom point, that's also a radius, and so on. So those are all radii of a circle. Okay, so the sphere is a relatively basic diagram. Now, the next that we're going to talk about is the volume of a sphere. So once we know what a sphere is, we can find the volume of it. How much space does it take up in 3 dimensions? Now, we need to derive the formula from volume, just like we do in all other 3D objects, geometric objects. We've derived it from something that we already know. Okay, something that we already know. Well, spheres, and this is actually discovered by Archimedes, are related to cylinders. Okay, so I'm going to draw a cylinder as a sphere, and I'm going to embed a sphere into it. So their volume is related to the volume of a cylinder. Okay, so here's my cylinder. And inside my cylinder, I'm going to draw a sphere. Okay. The sphere and the cylinder are related in size. Okay. So here's my cylinder radius. That's my cylinder radius there. And this is the height of the cylinder. That distance there. Now inside my sphere, I also have a radius from the center to the edge. Okay. And the radius is what determines every point in the sphere again. All right, so we're going to relate the volume of the cylinder to the sphere. So the volume of the cylinder is equal to the area of the base times the height. Okay. Now, when we put in numbers here, pi r squared times h, put in our variables. Okay, so notice that the sphere is inside the cylinder. Now, if the sphere and the cylinder have the same radius and height, then that means that the sphere will have less volume because there's extra space around the sphere that is part of the cylinder's volume, but not the sphere's volume. So the volume of the sphere will be equal to a fraction of the volume of the cylinder. Okay, so the volume of the sphere is equal to a fraction of the volume of the cylinder. What the fraction is determined by the ratio of the sizes, and in order to find this, find out how the sizes relate, we fill up our sphere with water. Okay? So we fill our sphere with water, and then we dump the water into the cylinder. And so it turns out that the sphere fills up only part of the cylinder, as one might imagine. And if we were in real class, then you would do this experiment. So then, as you will discover, the rest of it, you'll fill up the bottom half of the sphere and fill up the cylinder. And so that means that there are 3 parts of the sphere to 1 part of the cylinder. So the volume of the sphere is actually equal to 2/3 of the volume of the cylinder. With the same base and height. Okay. So we're going to finish out the calculation for the volume formula by substituting in the volume of the cylinder, keeping our 2/3. Two-thirds times pi r squared h. It just so happens that the h, the height of the cylinder here, is equal to is equal to the sphere dimension of radius, okay, as we discovered above. Okay, so the height is going to equal the distance from here to here is also radius. The distance from here to here is also radius. So height is going to equal 2 radii. Okay. So what we have here is we're going to substitute in that for our height. And when all is said and done, we simplify this expression by multiplying the 2 times the 2/3. So we get 4/3. The pi is left alone. The r times r squared becomes r cubed. Okay, and this is the volume formula that you're probably most familiar with. 4/3 pi r cubed. And so the derivation is important to note down for the final. So you'll have a chance to look at that on the final probably, maybe. And so once we derive the volume of the sphere formula, we can go ahead and use it in an example. The volume of a basketball. A regulation-sized basketball used in college and NBA by the men has a circumference of 29.5 inches. College women and WNBA use a basketball that's 28.5 inches in circumference. So the circumference, is 29.5 inches. How much air does it hold? Or, in other words, we're going to find the volume. So let's start out with the circumference is equal to 29.5 inches. Okay. Volume formula has radius, as you can see here. So we need to find the radius. Now we know that the circumference is equal to 2 pi r, okay, which is the radius, the circumference formula in terms of radius. And we're going to substitute the 29.5 inches for the c here. Okay, so 29.5 inches equals 2 pi r. And to get r by itself, we're going to divide both sides by 2 pi. That way those will cancel. Then r is going to be about equal to 25.5 divided by 2 pi. Now we know that 2 pi is 6.28, so 29.5 divided by 6.28 is about 4.7 inches. Okay. Now, since we have the radius, we can go ahead and calculate the volume. Volume formula, I'll go ahead and write down the volume formula and then substitute in the variables. There's only one variable needed for spheres, that's the radius. Don't forget our units. Okay, don't forget your cubed. Okay, so I multiply 4/3 times 3.14 times 4.7. Well, let's go ahead and write that down. Okay, so we're multiplying those 4.7s 3 times, or you can do that, use the cubed on your calculator, like the caret power key. And then we times it by 3.14, times by 4, divided by 3. And when all that is said and done, we get about 435 inches cubed for volume. Now we're going to talk about the surface area of a sphere. The surface area of a sphere is the area on the outside. No, it's not easy like a prism where there's just the outside is just polygons. So we're going to take a look at the sphere area by drawing a circle. And then we're going to make it into a sphere. Label the radius. Okay, that's my sphere. And I'm going to look at the surface area. The area of this is all curved, and so that makes it really tricky. And it turns out that the area of the surface is related, of the sphere, is related to the surface area of the cylinder. Okay, we're related to cylinder again by drawing a cylinder that has the same, radius and height. Okay, so the cylinder's radius is here. Here's the height. Okay, so we're going to relate these together. In class, if we were to do this in class, we take a string, okay, and we take this string and we'd wrap it around the sphere like this. Start at the top, and start wrapping it around like this. And we wrap the string all the way around the sphere. Now the string does have some width to it. Okay, and then we'd stop and mark off the string. So there is some width to it. It's curved. The string is bendable, so it can fill up the curved surface. Once we mark that area of the string, we take the string and we wrap it around the cylinder. Okay, so we start the mark here, going around the cylinder. And we go all the way around the lateral surface of the cylinder. Wrapping the string, making sure it's all tight and thick. I'm not drawing all the lines that you would see. All the way around the back. Okay, and then we mark it at the end here. Okay. And we would notice that the length of the string is the same for the surface area of the sphere and the lateral surface of the cylinder. So the surface area of the sphere is equal to the lateral surface of the cylinder. Okay, amazingly enough. And so we can go ahead and compare these these lengths, or the areas, is equal to the lateral, the area of the lateral surface of cylinder go on there. The lateral surface of the cylinder of same base and height, same radius and height, I mean. Okay. And so by formulas, we do know what that is. Okay. So the surface area of a sphere is is equal to the area of the lateral surface. Now the area of the lateral surface is a rectangle, which has a base and a height, a length and width. And the length is going to be 2 pi r because it's the circumference times the height. And that's equal to 2 pi r. Now remember that the height from the sphere is going to be the same as the radius here, radius up there, radius up there. So twice the radius. And that is equal to, when I combine the numbers together, the 2 and the 2 make 4. The pi comes along for the ride, and r becomes r squared. Okay? So that's the formula for our surface area of a sphere. All right, let's use it in an example. We're going to paint the basketball. So how about we have our basketball from regulation size, and we want to paint it another color besides orange. How many square inches is the surface so that you know at least how much paint to buy? Okay. So the surface area of the ball is what we're looking for. Okay. So I know that my radius is also equal to 4.7 inches from before. It's about equal to that. But it'll be good enough for our estimation purposes for our paint. And we're going to do the surface area formula. Surface area is equal to 4 pi r squared. So I write out my formula. 4 times 3.14 times the radius, which is 4.7 inches. Square that. Make sure you square it. And we get approximately equal to, when I do that on my calculator, 277.45 inches squared. Okay, so it's about that for our surface area. Some people have noticed that the surface area is 4 pi r squared. Surface area, is that equal to 4 areas of circles with the same radius? As the sphere? Why is that? Well, it's a nice question, but beyond the scope of our course. Anyway, this is the video on volume and surface area of a sphere with some examples. We'll go ahead and wish you a good day, and thanks for watching.